Hello scholars, welcome to our first day of review. And the very first thing we're going to review is limits. Okay, so you can pause the video right now and take about 5 minutes to do the do now. And just play it again so we can go over it together. Okay, now that you've done the do now, I'm going to go over it. Alright, so the problem says the graph of the function f shown above. Which of the following statements is false? You have 5 options, and I'm going to go through some of them. Alright, so A says, limit as x approaches to f of x exists. Well, for it to exist, it has to meet at the same y value from left and right, so from both sides. Well, let me check. I'm going to focus at the number 2. It's right here, number 2. Coming from the left, coming from the right, and I arrive at the same point, so it does exist. So this one is true. Moving on. Limit as x approaches 3 of f of x exists. So I'm going to focus on 3 now. It's right here. So from the left side, I end up at 5. From the right side, I also end up at 5, so that statement is true. Next up, limit as x approaches 4 of f of x exists. Let me check. From the left side, it ends up at 2. From the right side, it ends up at 4. So they have different y values from different sides, so the limit does not exist. So this is a false statement. Okay? We'll keep going, and just to check the rest, limit as x approaches 5 exists. So I'm going to focus on 5. It's right here. I'm going to erase my blue coloring. So I'm going to come from the left side. I end up at 6. Coming from the right side, I end up at 6. So I do meet, so I exist. That's a true statement. Last one, function f is continuous at x equals 3. We're going to go over continuity more tomorrow. But continuous means there's no breaks, no holes, no jumps, asymptotes, etc. Okay? So that's just a quick review. So none of any of these. Cool, let's focus at 3. Right here. If I look at my graph, just want to make sure that it's smooth through 3. Oops, there's no problems there. I was just very smooth. I kept on going. So this is a true statement. So we'll cross off all the truths. The correct answer is C. Alright, so for limits, we have to remember that limits is the y value of the function. So when you're giving the limit of a function, you're giving the y value of the function. I have 3 techniques listed out here to help us review how to solve limits in general. The first one, the very, very first one, and the coolest one, I guess, because it's very straightforward, is direct substitution. All it means, in this example, limit as x approaches -2 of x to the third plus 6x squared minus 16. The first thing you always want to try is, can I just plug in the x value? Yes, you can for this example. So I'm going to plug it in. -2 to the third plus 6 -2 squared minus 16. And you simply solve it, and you get your final values. I'll leave that to you guys to solve. Next up, another example. So the first thing I'm going to think about, well, can I just plug in the x value for, let's try, 4 squared plus 9 over 4 squared minus 1. Perfect. Just plug it in, solve. So if you do this by hand, it'll be 16 plus 9, 25, and 4 squared minus 1, 15. Yeah, 5 over 3. Okay, sometimes though, there's a problem. For example, if we plugged in -1 in this example, you can try it, you're going to get a 0 over 0. We do not like that. We don't like 0 over 0. If we remember, this is called indeterminate form. All that means is this tells us nothing. We're not getting any information from it. So, one thing that we can do to help us is to factor the expression, cancel the common factors in the numerator and the denominator, then you try substitution again. All that means is, let's try to factor, all right? So we're going to focus on the top. What can we factor out? We can factor out an x, and we're left with 1 plus x. Now let's look at the denominator. We can factor it by, I know you guys call it dots. So I'm going to do x plus 1, x minus 1. I'm going to take a pause here and see if I can cancel any common factors in the numerator and denominator. Well, I can. I can cancel 1 plus x and x plus 1 because they mean the same thing. So I'm left with x over x minus 1. And at this point, I'm going to check, well, could I just plug in the limit as x approaches negative 1 here? Yes, I can. Try it. Negative 1 over negative 1 minus 1. You're going to get negative 1 over 2. And that is the limit. Okay, so all I needed to do was factor it first, cancel a common factor in the numerator and denominator, then go back to direct substitution. Let's try another one. So if you try to plug in 7 in this problem, I promise you that you're going to get a 0 over 0. And we don't like that. So we're going to try to factor. The numerator becomes x minus 7, x plus 7. In the denominator, I can't really do anything, so I just leave it as x minus 7. Can I cancel any common factors? Yes. And I'm left with x plus 7. Now, can you apply the limit now? Can you plug in the limit? Yes, you can. So go ahead and do that. It'll be 7 plus 7, which will give us 14. So that is the actual value, 14. The last technique, and this is probably the most useful because it works all the time. And, well, not all the time. It works for all the problems that you may encounter in the AP exam, such that when you plug it in, you get a 0 over 0, which we hate. Okay, it doesn't work. So this is what we do. This is the same problem as what we just factored, but we can also apply L'Hopital's rule. Simply by focusing on the numerator, taking the derivative of it. So the derivative of x squared is 2x, and the derivative of minus 49 is 0, because it's a number. You kill it off. Well, that's a killing. That's not an x. Okay? And then you do the same for the denominator. The derivative of x is 1, so the new denominator is 1. Once you've taken the derivative, you're going to check if you can just plug in the limit now. Well, let's check. Well, yeah, you can just plug in 7. Let's do it. 2 times 7 equals 14. This is the answer. Now, take a minute. This answer, 14, is the same as what we got when we did factoring earlier. Okay, so for the same problem, you can either factor or you can use L'Hopital's rule and you will get the same answer. That's great. So let's try a little bit more trickier looking problem. And I want to show you that you can do it because you know how to take derivatives. So if I plug in 2, in this next example, you're going to encounter a problem, you're going to get a 0 over 0. We don't like that. So what we can do is, well, let's think, can we factor this? Probably can, but that's way too complicated. What we can do instead is apply L'Hopital's rule. So look at the numerator, focus on it. I'm going to rewrite it in a way that's easier for us to take the derivative of. So I'm going to say 1 minus 4x to the negative 2. I did that by simply taking a denominator and bringing it to the top. Okay? That's not the derivative yet. I just simplified it for us. Now we can take the derivative by circling the exponent, bringing it down, and subtracting 1. We're very good at this. So the derivative is 1 becomes nothing, and I get negative 4 times negative 2, which is positive 8, x, and the new exponent is negative 2 minus 1, which is negative 3. This is my new numerator. I'm going to do the same work as the denominator. Rewrite it real quick. 1 minus 2x to the negative 1. Take the derivative, okay? So I'm going to get, this gets killed off. I get negative 2 times negative 1, you get positive 2. Negative 1 minus 1, that becomes your new exponent. So, in short, my new function is 8x to the negative 3 over 2x to the negative 2. I'm going to look at this and take some time to cancel what I can and make it simpler for me, because right now it looks kind of weird. So I'm going to cancel this, this becomes 4. I could combine the x's by simply bringing this whole thing down, which will make the denominator x to the negative 2 plus 3, which will make the denominator just x to the 1. So I have 4 over x. I'm going to take a second and say, well, can I plug in the limit at this point? Yes, I can. Just plug in 2. 4 over 2, which is 2. This is the answer to your limit. Now, I know that was long. I know it was. But because you know how to do the derivative, if you are patient, you can solve this problem. Okay. Next concept to review. Whenever you see x approaches infinity, well, we can't plug in or substitute infinity. Infinity is not a value. We have to use the concept of dominance. This is how it works. So sometimes you're going to have examples where the numerator exponent of the leading term, meaning the largest term, is bigger than the exponent in the denominator. Think of it this way. If my numerator gets larger and larger and larger and larger and larger, meaning such a big number, then eventually my entire number is going to go to infinity. So anytime the leading term has a greater power in the numerator, your limit is going to go to infinity. Same for the next example. If I look at the leading terms and ignore the rest of the terms, the numerator has an exponent of 3. The denominator has an exponent of 2. The numerator is bigger, so the limit goes to infinity. Wow, that is, I hope you make better infinity soon. Okay. Sometimes, though, the numerator has equal power as a denominator, such as this example. In this situation, you simply take the coefficients and divide them, and this is your limit. The same for the next example. I'm going to focus on the largest term. The largest term. But hey, don't forget this little 3 exponent there. It didn't go away. We have to distribute that exponent of 3. So it'll be negative 2 to the third, x to the 2 times 3 is 6, over x to the 6. Now, we just take negative 2 to the third over 1. You divide them. That'll give you negative 8. That's the limit, negative 8. Okay, next one. This is a little bit of a comprehension problem. We can do it. So it's saying when you take the limit as n goes to infinity, you're going to get 1 over 2 as the answer. Okay, so you know the answer should be 1 over 2. Now what we can do is follow the steps. I'm going to take the largest term here, the largest term here, and since they have equal power, I can divide their coefficients. Meaning I can do 6 divided by negative k equals 1/2. And all you got to do is solve for k. You can cross multiply, you're going to get k equals negative 12. So you've just answered the limit problem. I'm going to pause right here, and I'm going to record the next part of this review in the next video.